In this video, I demonstrate the application of a PID controller optimized by the Firefly algorithm for the liquid level control of an interacting two-tank system. The liquid level is measured by the US-16 ultrasonic sensor and sent to the Arduino via pin A2. The signal is then converted to distance in the ADC to distance block and passed through a low-pass filter to remove noise. The filtered signal is compared with the reference value to generate the error, which is fed into either the FA PID or fuzzy PID controller, depending on the manual switch position. The controller computes the output control value within the range of 0 to 255. Finally, the control signal is transmitted to the DC motor through the Arduino and the driver circuit. This is the Arduino R3, the central controller of the system, sending commands to the L to 9 8P motor driver to control the DC pump. The ultrasonic sensor US-16 measures the water level and sends feedback to the controller. The R365 pump powered by a lithium battery transfers water through valve R1 to the second tank, while valve R2 at the bottom releases water to simulate the two-tank interaction system. Now we move to the experimental run. This part will be fast-forwarded for easier viewing. In the first experiment, we open valve R1 to 100% and valve R2 to 25% with the reference liquid levels set at 10 centimeters. As we can see, the response follows the reference level quite well with no overshoot occurring. In the second experiment, I increase valve R2 by another 25%. You can see that the water in tank 2 starts to flow faster. This can be observed through the water levels in both tanks. In the first experiment, the levels of the two tanks were almost equal, but in this second experiment, the water level in tank 1 is slightly higher than in tank 2. This also causes the nonlinear disturbance of the system to increase significantly, but it can be seen that the response signal still tracks the reference signal quite well. In the next experiment, I reduce the valve opening by 25%, meaning that valve R1 is now open at 75% and valve R2 at 50%. You can see that the water level in tank 1 rises rapidly, and the difference in water levels between the two tanks becomes more noticeable. The reason is that the amount of water flowing from tank 1 to tank 2 is now only about 75% compared to the previous experiment. This time, the system's nonlinearity becomes more apparent than in the previous experiment, resulting in higher signal delay and noise. You can see that the response shows some overshoot and oscillation but quickly stabilizes. Although the reference signal fluctuates around 0.3 centimeters, the system maintains high stability, demonstrating the effectiveness of the PID controller optimized by the Firefly algorithm. This time, I did not change the valve positions, but instead varied the reference signal from 10 centimeters down to 8 centimeters, and then from 8 centimeters up to 12 centimeters due to the system's nonlinearity and signal delay. Overshoot and oscillations appeared during the reference transitions. However, the system quickly stabilized and showed excellent tracking performance. Once the steady state was reached, the response remained stable with almost no oscillation. In the final experiment, I compared the FA PID controller and the fuzzy PID controller under the same conditions and valve openings. From observation, the response speed of the FA PID controller, shown in the video on the left, is slightly faster than that of the fuzzy PID controller on the right. This demonstrates the advantage of the PID controller optimized by the Firefly algorithm in achieving quicker and more accurate response. Another remarkable feature of the FA PID controller, as you can see, is that once the system reaches steady state, the response shows almost no oscillation around the reference level. In contrast, with the fuzzy PID controller, you can observe small fluctuations of about 2 mm around the reference value. This can be clearly seen with the naked eye in the experimental video on the left side of the screen. Thank you for watching this experiment on the Firefly algorithm-optimized PID controller. Your support means a lot, and I hope this research inspires more ideas in intelligent control systems. See you in the next project.